Okay, almost at the end. We got the second last chapter here, household chemicals. All right, here are the learning objectives. Okay, so cleaning. So we've always liked to have clean areas. So soapworts or soap berries had soapponins, which made a soapy lather. So we could take that and try and clean that way. You just use water. So wood ashes contained potassium and sodium carbonate and had some detergent properties. So sodium carbonate, we still sell it today. We still use sodium carbonate as washing soda. So this is the way we used to do it, hitting things with rocks in the river. Okay, so nowadays we have a magic a chemical we call soap. Soap is really magical. Uh, so if you don't believe me, go and stick your hand in some oils. So something like canola oil. So put some canola oil in your hand, and then try and wipe it off. You're still gonna have this little tiny thing, this sheen of oil. You can run water over it. It's lipophilic, so it's hydrophobic. It's not going to dissolve in the water. You can even run hot water over it, and then by viscosity you can get some of the oil off that way. But you're still gonna have this tiny film of oil on your hands. But what do you do though? You just like, I don't know what to do. You take you take soap and you run it under water and you agitate, you rub your hands together, and then all the oil comes off your hand magically down the drain. So you got oil, you turn it into something that does not dissolve in the water, you turn it into something that dissolves into water. And that is the power of chemistry there, my friends. And we do it by making soap, by using soap. And how you make soap, you take a triglyceride fat, these are any fat, and you hit it with sodium hydroxide lye, and that breaks apart into the sodium salt of the fatty acid. And these are the typical anionic surfactants. So, and here is a surfactant molecule. Of this, any case, this is the anionic surfactant, and we can approximate it there with the negative ionic head and then the squiggly tail. And how that works is you take an oil droplet, and the squiggly tails are nonpolar, and they all surround the where the oil part is, and then the negative charge is on the outside. Now this whole thing can be dissolved into water, and this whole thing is called a micelle. So another thing we talked a little bit about with biochemistry, what this kind of looks like is a cell membrane. A cell membrane is a phospholipid bilayer. So instead of, and these we have carbonates, but imagine a phosphate on the top, and then a phospholipid, a bilayer, two of them. So the two ends of the tails form a structure. It has a skin around the cell, and then the negative charges on the outside. So so that means that your cells have a skin layer that's literally two molecules thick, and it goes together by solubility properties. This is one of the reasons I love chemistry. It's amazing. It's amazing. All right, but here, this is how soap works. It forms a micelle, and then you have to agitate your hands. You have to rub your hands together to form the micelle. And you need water to form the micelle, so keep that in mind. And the oil in soapy water form was called an emulsion, and an emulsion is defined by the Tyndall effect, a scattering of light. So if you have soapy water, if you have oily soapy water and you hit it with a laser, it'll scatter the light. So the soap is the emulsifying agent, and the nonpolar substance in the water is called a surfactant, so surface active agent. So, okay. And problem with soap. So soap is great, at least traditional soap, and the if there's water, hard water has calcium or magnesium ions in it. My water in Maui has it's really hard water. I get soap scum. It precipitates out the calcium magnesium stearate, the fat there. Calcium magnesium stearate is a precipitate, and it'll precipitate down. How do you get around that? You can do this. You can add things like washing soda, so sodium carbonate, also TSP. These both raise the pH and get out the magnesium ions. Uh, Also, water softener is another way you can do. I don't use a water softener. I just deal with the hard water. But in hard water, you don't get as you don't the water isn't as soapy in hard water. And but anyways, a water softener here, it will replace the calcium magnesium with sodium ions. And there was a synthetic in World War II. We the raw materials for soap, and it was synthetic detergent was used instead. Uh, this one here. But the problem with that is it was non-biodegradable, and so alkyl benzyl sulfonates, or ABS, these ended up having lots of foam places where you shouldn't see foam, like in rivers and whatnot. So nowadays we have linear alkyl sulfonate detergents. So this way they are biodegradable and they can be eaten. They do produce an oxygen biological oxygen demand, a BOD, on the environment because then the microorganisms need to eat them, but they are biodegradable. Also, laundry detergents. So, talked a little bit about soap. Now we're going to change topics. Talk about laundry detergents. So, what's in laundry detergents? Surfactants. We already talked a bit about surfactants, the soaps, builders, and brighteners. So, surfactants. And we've talked about the soaps. We talked about the anionic ones. So the ones that we've been talking about so far are anionic, which means that it's negatively charged. So there's cationic surfactants, non-ionic surfactants, and amphoteric surfactants. So anionic are negatively charged, cationic are positively charged, non-ionic have no charge, amphoteric are both positive and negative charged. It depends. Their charge depends on the pH. So so uh, betaine is an example of an amphoteric surfactant. So, all right. So builders increase the detergency of the surfactant. So these are like sodium citrate, sodium triphosphate, and sodium hexametaphosphate. These sequester the calcium magnesium ions. So those are the builders. They make it better. And because phosphate is can cause eutrophication, especially in the Mississippi River Valley, we some states have banned their use. Use zeolite instead. You can use EDTA as well. That's another option. Ethylene diamine tetraacetate. That's something that can be used instead. Also, brighteners. Brighteners are added to make clothing appear brighter and newer. So one of the things, if you ever do this, go to a blacklight party. Blacklight party is one where you dim the lights and have black lights going on. It's fun to play with detergent, and those detergents appear so bright and under a black light. So you learn a lot about people in a black light party. Your teeth fluoresce, for instance, so you can find out who has not real teeth, for instance. But they're kind of fun. And detergent, you can take highlighters and stuff. It's fun. But brighteners, like in detergents, they get really really bright under black lights. So recently we've been having more and more liquid laundry detergents. So they can be built. Many of them have enzymes in them too, not listed in here. You can formulate them with sodium citrate, sodium carbonate, or zeolites. Unbuilt are high in surfactants and without builders. So the builders just mean that they make the surfactants more effective. Okay, so changing topics, going to dishwashing detergents. So automatic dishwasher, I love my dishwasher. It's so amazing. But they tend to be alkaline. So they have sodium triphosphate, sodium carbonate, sodium metasilicate, and a bleach, and a small amount of surfactants. Maybe sodium hydroxide too. So Moving away from the phosphates, though, those tend not to be used in dishwashers anymore. Sodium carbonate is becoming more and more common. Uh, and liquid dishwashing detergents, they're pretty heavy in surfactants. So LAS or uh, Cocamide DEA. So those are very common for the surfactant loads in the dish soaps. Okay, so fabric softeners. So why do we need fabric softeners? First of all, so all biological things are negatively charged at the surface. So uh, much of it has to do with cell membranes being phospholipid bilayers. And generally speaking, when you add negative charge to things, to biological things, they get larger. And when you add positive charge to things, they shrink. Biological surfaces, I mean. So, how do you make a natural fiber feel softer? One of the ways to do it is to add positive charge. And what quaternary ammonia salts do is they add positive charge because they're cationic surfactants, so positively charged surfactants. They're also antimicrobial. So if you wonder what's in those antimicrobial wipes, it's quaternary ammonium salts, or quat, sometimes referred to like that. So fabric softeners and dryer sheets contain this. Uh, Bleaches, so whiter whites, they're oxidizing agents. The most common one is sodium hypochlorite. You can also have sodium perborate sodium percarbonate or sodium perborate. So the sodium carbonate peroxide, that's what OxyClean is. So if you wonder what OxyClean is, it's washing soda with peroxide in it. And if you put that in, if you use that, you have to use hot water though. So put that in hot water, it'll release the peroxide, and then that'll oxidize the stain molecules. So there are many all-purpose cleaning products found in the home. These include household ammonia solutions, baking soda, and acetic acid vinegar. So many of them also have surfactants in them as well. So, and it can also have isopropyl alcohol. Okay, so special purpose cleaners, toilet bowl cleaners, usually acidic and can remove calcium carbonates. Scouring powders, these have abrasive materials. The ones that I use actually have oxalic acid in them. That's also the stuff that's in taro. But it may contain surfactant bleach. Yeah, they can have bleach too. Glass cleaners, isopropyl alcohol, ammonia, and sometimes vinegar also have surfactants as well. Drain cleaners. So these are dangerous. They're very alkaline. They will saponify grease, and the reason is so you can break down the grease. And it can also have bits of aluminum because when it dissolves in water, it will release hydrogen gas, and that can help agitate the clog. Some can have bleach to tear apart hair. The drain cleaner, sodium hydroxide will also degrade hair too, so that will work as well. Oven cleaners have lye or caustic lye, so caustic can also mean sodium hydroxide. They usually use the word caustic when they have oven cleaner, so there's caustic and it's sodium hydroxide. Breaks down the grease. Okay, and organic solvents you can use to remove paint, adhesive, waxes, and other materials. Most are volatile and flammable, so these are things like turpentine or mineral spirits, paint thinner. So these types of things. Well, be careful. It can displace oxygen as you use those and get you a little bit of a high that way. Paints. So what is a paint? So paint is basically a pigment, a binder, and a solvent. Okay, a pigment is a color, a binder is a monomer, so if a polymer, monomer, and a solvent, what happens is the solvent evaporates. So you put the paint on, the solvent evaporates, and then the binders polymerize, keeping the pigments in place. So it's good old plastics. So that is how they work. And varnishes and oil-based coatings. So those are I'm used to using the water-based, but I guess I have used oil-based, and hydrocarbon-based things like spray paints or something like that. Okay, waxes. These are long-chain fatty acid and long-chain alcohols. So paraffin wax, that's the stuff that candles are made of, is a mixture of long-chain hydrocarbons. And also for natural waxes, we can replace with using silicones. So, and these waxes serve both plants and animals as providing protective coatings. We have that a little bit. We release an oil called sebum, sometimes called sebum. So humans are very oily. So if you look at other animals like cats and dogs, we are extremely on the oily end. And our hair and our skin is very oily compared to other animals. So they probably think that they probably think we're really greasy. So knowing with the humans, what the other animals think of us. But we can use silicones. That can also be used in hair conditioner. I guess we'll get to conditioners soon. Okay, cosmetics. The U.S. Food, Drug, and Cosmetic Act of 1938 defined cosmetics as articles intended to be rubbed, poured, sprinkled, or sprayed on, introduced to, or otherwise applied to the human body or any part thereof for cleaning, beautifying, promoting attractiveness, or altering the appearance. The main difference between drugs and cosmetics is that drugs need to be proven safe and effective before they can be marketed. So which kind of saying, well, you don't really have to do this. You'll see a lot of claims. I was an intern at Bath and Body Works in Victoria's Secret. That was a fun job. Some of the claims like if you look at the fragrances, they make lots of like stress relief and stuff like that. It's really the scent, and it's a self-fulfilling prophecy. Okay, well, let's talk about skin and creams and lotions. So and the corneal. Okay, so it's the cosmetics are applied to the dead cells of the corneal layer of the skin. So in the epidermis. So that's the top layer, and skin and hair are all made of keratin. So one thing to think about, and fingernails too. Keratin, it's all the same protein. So lotion, so we talked about emulsions with soap, like when you're cleaning your greasy pan or your greasy hands. That is an oil and water emulsion. So a lotion is a little bit of oil and a lot of water. A cream is a little bit of water and a lot of oil. And they both use surfactants to get those micelles. So, and the cream lotion forms a protective film over the skin, and it keeps the moisture in. So, emollients protect the skin by coating it and softening it. So that's the oil. Moisturizers hold the moisture of the skin. Humectants, so glycerin, lactic acid, attract water, and they're also very oily too. Like they're very slippery. At least glycerin is. Okay, sunscreens. So sunscreen lotions block UVB light and allow UVA through. One of the things that UVA is the leading cause of wrinkles. So a wrinkle is when you, let me go back up. So you have the dermal layers of the skin going further down. A wrinkle is when there is damage to the lower layers of the skin, and then the skin folds over that. And wrinkles can be caused by repetitive motion too. I mean, like if you see an old person, you can kind of like, oh, that person has a perpetual smiley face or a frowny face. You can kind of, wrinkles kind of appear based off of how much that person has smiled or frowned. But one of the major causes of wrinkles, or the largest cause, is UVA radiation. So the ultraviolet light scarring the lower layers of the skin. So used to have para-aminobenzoic acid. Was water soluble. Now they tend to contain acetyl methocinamate. So it's insoluble in water. There's a bunch of other chemicals in them, and they absorb at different wavelengths. Uh, but the SPF refers to UVB light, and sunscreens work very well with UVB. They don't work as well with UVA. So if you see a sunscreen that says anti-aging, that means that it's got a UVA blocker in it. So, but SPF 15 means that well, you can look at it one way. It lets 1/15 of the UVB through. But then you could stay outdoors 15 times longer than with no protection. So a sunblock, these either have zinc or titanium oxide, so zinc oxide, titanium dioxide, and that's just like clay, and well, they are clays, and it blocks the UV radiation that way. So you have two types. You have the organic type, the organic being carbon containing, that you have the molecules oxybenzone is another one. They absorb the ultraviolet B radiation and turn into heat. And then the sunblocks, they just plain old block the sun, and they work for UVA and UVB. Okay, lipsticks. It's similar to creams, but they add a dye to it, so oil wax, and well, I guess I'm thinking of lipstick, the coloring, but I guess lip balms, similar idea. They contain an oil wax, and they hold moisture against the skin. Which is also, if you live somewhere cold, you can get chapped lips from really cold air. You can also get it on an airplane. So just if you want to put lip balm on. Eye makeup used to accentuate and decorate the eyes usually contains waxes, soap, fats, oils, and pigments. So with the eye makeup. Deodorant, antiperspirants. So deodorant just contains smelly stuff and maybe a germicide to kill odor-causing bacteria. Okay, so I should back up. We have two types of sweat glands. We have apocrine, and epicrine. Apocrine is what is on most of your body. That produces sweat, which is normally just water, salt, a little bit of urea. Apocrine glands, they are found in your armpits and your groin. And alongside sweat, they also release proteins. Bacteria eat these proteins, and then they release the butyric acid, the body odor smell. So that body odor smell is actually from bacteria that eat the proteins excreted from your apocrine glands in your armpits and groin. So what antiperspirants do is they stop that. They constrict the pores of sweat glands, prevent the perspiration at your armpits. So typically is where you put deodorant. I guess you could put it in your groin too, but I've never known anyone to do that. Toothpaste. Okay, toothpaste has a detergent. Actually, the detergent in toothpaste is pretty strong. Detergent and abrasive. So abrasive is usually either what is that stuff called? Baking soda or diatomaceous earth. So like little tiny fossils. So the detergent, what that does is that it lifts the plaque off of your teeth. So you brush your teeth, and then that'll lift. It's really heavy detergent. It lifts the plaque off of your teeth, and the abrasive there to scrub them, much like you're cleaning your stove with the abrasive. Same idea. But your teeth are pretty hard, so it's okay. Can also have flavoring agents, coloring agents, sweeteners, and thickeners. So other things. Also, most contain fluoride. So that way it'll help harden your teeth too. The sensitive ones, what they contain are potassium nitrate. The way that works, so if you in your teeth, you have the enamel of your teeth, and then you have the dentin, and then you have a nerve cell, and alongside you have ion channels that you can carry signals. So what the sensitive teeth do is they over time using the sensitive toothpaste will kind of deaden those channels. They'll kind of stop working, so then you won't feel them anymore. So if you're wondering how that sensitive toothpaste works, be careful if you are a male and you're using the sensitive toothpaste, the one, at least the ones that have potassium nitrate in it, because ingestion of potassium nitrate can cause impotence. So be careful with that. Well, in females too, it causes blood pressure to drop in both males and females. Just to warn you, taking any nitrates. So. Okay, this slide is not entirely accurate. So perfumes have many ingredients divided into notes. The top note, the middle note, and the bottom note. They call it usually the top note and the bottom note. Uh, American perfumes formulations tend to be really heavy on the top notes. So, like, if you walk into some stores, you're like it knocks you like Abercrombie and Fitch. If you walk in Abercrombie and Fitch, it feels like someone smacks you over the face with the fierce smell. That's a top note. And European fragrances tend to have more bottom notes, which kind of stay with you longer. A perfume has the most of the fragrance in it. Then a cologne has a medium amount, and then the lightest one is a splash. So if you buy a splash, that has the least amount of perfume in it. So most Americans buy colognes. We don't typically buy perfumes anymore. That's more of a European thing. And so if you want to make a lot of money, you can be a perfumer. It takes 10 years to train someone as a perfumer, though. The biggest company is IFF, the International Fragrances and Flavors. There's several others, though. You can go and you start as an apprentice program, and it takes someone 10 years to train him or her to be able to make perfumes. So, and it's a very lucrative job. So, they can, it's right now, it's a job that only humans can do. So, but if you're interested, let me know. I can get you in contact with people. Here are the various, well, it says flowery, unpleasant, maybe not, I don't know, the muskier can be okay. And, okay. So moving on with hair chemistry. Okay, shampoo. What is shampoo? Shampoo is basically bad soap. So, or not very effective soap. So the thing with our hair, we have sebum in our hair. It's the oily substance that we have, and too much sebum is a bad thing. Also, our hair is dirty, but you want to wash your hair. You want to get rid of some of the sebum, but not all of it, and you want to rather than strip it dry. So shampoo, like I said, is essentially, it's kind of not very high functioning soap. Bar soap works very well, so if you want, you can take hand soap and wash your hair with it, and you will strip your hair of all the oils, and then your hair will feel really dry. So shampoos, like I said, are just not highly functioning soaps. Conditioners usually contain one of two things. They can contain protein, and they can also contain lipids, so fatty substances. It's in this slide. It says quaternary ammonium salts. That's the same idea to make hair feel softer. Same thing with the fabric softener. The quaternary ammonium salts, you actually see those more often in shampoos. Those are the detanglers, and that's the conditioning shampoos. So that's, if you wonder how you can condition and shampoo at the same time, you add quaternary ammonium salts. They also, like I said, detangle for people with curly hair. So, and although conditioners, they typically have lipids in them, the silicones are being used more readily in that as well. So you have an alkali, or you have a shampoo is a soap, not very high functioning soap. Conditioner is usually fatty substance, and or has protein. What the protein does is it helps, because your hair is made of protein, and it helps fill in the cracks of your hair, can give your improve the tensile strength of your hair with the protein. Okay, and what is this? This is the hair. Okay, so You have hydrogen bond in your hair. You have the salt bond in your hair, and then okay, I guess this was going for the attraction of the hair. Okay, and hair coloring. So you want to color your hair. Hair color is determined by two pigments: melanin, eomelanin, so also known as melanin, and pheomelanin. So eomelanin is brown, black, and pheomelanin is kind of red. So hair color, you can oxidize these. There's a couple different ways to do hair dye. Okay, so this is a very abbreviated uh, slide here. Uh, so hair is a biological surface. You hit it with a base like sodium hydroxide, it gets bigger. So the first thing you do when you color your hair, you hit it with either bleach or more typically sodium hydroxide. That opens up makes the hair follicle really big. Then you can do oxidative dyes like bleach, and what the bleach does, it will lighten the eomelanin and pheomelanin directly. Or if you don't want to do that, you can just get rid of the bleach and just use uh, sodium hydroxide, and then you can add a dye molecule in while the hair is blown up. And then when you wash the hair follicle closes back up, and then the hair dyes are inside the hair follicle from that. Those are the semi-permanent, demi-permanent dyes. That's how they work. And you can just do a temporary dye where you just spray it on the surface. Like if you want to be the Hulk, you can spray your hair green or something like that. That's like the temporary dyes. Or you can use Kool-Aid, for instance, to that those just stick to the surface of the hair, and they after a couple of washing, they tend to leave. So that's how you. There's the longer way of doing hair dye. You can have metallic dyes. So the Grecian formula here uses lead acetate, and what happens is that the lead acetate reacts with the cysteine in the hair to form lead sulfide, and then that darkens the hair that way. And that came from the Greeks when they would swim in their baths. They had the lead pipes, and the Greeks, they found out that like if they had gray hair, it would be stained black from the lead that was in the water there from the time they spent it in there. So there's other types of metallic dyes, and they're not used as frequently anymore. Word of caution: if you use a metallic dye, uh, do not put peroxide on it. If you do, you can catch your hair on fire. So hydrogen peroxide and metals are a bad idea. So do not put hydrogen peroxide on your hair if you use a Grecian formula or some other metallic dye. Okay, a permanent wave. So a permanent wave, I've mentioned this before, they affect the disulfide bonds. So what you do is so if you have straight hair and you put your hair in curlers and you add thioglycolic acid or ammonium thioglycolate. Uh, Ammonium thioglycolate is very common rather than thioglycolic acid. What that does is it reduces the bonds, and then you treat it, you oxidize with hydroperoxide to oxidize it and reform the disulfide bonds, and then your hair will stay in place. You don't have to use peroxide. You could just leave it on for a couple of days and it'll react itself. But most people want to get it done and over with very quickly. So, yeah, hair relaxers work the same way, except it's curly to straight hair, and you can just use gravity to straighten hair that way. Okay, hairspray. Hairspray has a binder. It's the same, similar to paint. Hairspray is just a binder and um, a solvent. So you spray hairspray or mousse, and then the solvent evaporates, and then the binders polymerize, and now you have your hair staying in place. So it's plastic. Hair removers, these are called depilatories. Depilatories. So many of them are very alkaline. So strong basic soluble sulfur compound, very alkaline sulfur compound that binds to the hairs and it can be washed off and the hair was removed. So hair restorers like Rogaine, yeah, this is another accidental product. It was for treated for high blood pressure, but the chemist ended up getting very hairy arms. And like, oh, we can use this to grow hair instead. So applied to any skin, hair follicles located, it can grow hair back. So okay. So you are the consumer. You are the one using the stuff, and so be careful when you do them. And no one knows your body better than yourself, and especially some people have allergies to certain things. So keep that in mind. And some people just don't know. Like I told, like I mentioned, the metallic dyes and peroxide. That's been a bad thing if your hair catches on fire from that. But luckily, metallic dyes are not used as often anymore. Although the Grecian formula does seem to be coming back on the market. So you are the consumer. You should be informed, and you've taken this class, so hopefully you're more informed now. So one more to go, folks.